Hello my dear friends, welcome to our channel. So in the previous lecture, we started the lecture with a very curious question that how the molecule of the solids is regaining its original position even after the deformation too. And even we got the answer for this question in the previous lecture. It is an intermolecular force between the molecules which is bringing back those molecules which is deformed to its original position. So I'm starting from there. I'm giving a very quick review for that one. You can see here, I'm taking a spring. I'm going to apply the deforming force at the second end. Here it is fixed and the second end is the free. Here I am going to apply the deforming force. I'm going to pull the spring. That means I'm applying the force in order to change the size of the spring. Yeah, and you can see the size of the spring has now been changed. Still now deforming force is there. As I'm applying the deforming force, the molecules of the spring is going to change their positions. Initially, this molecule is present here and now this molecule has been changed here. That means there is a change in the position of the molecule due to my deforming force. As you can see, the change in the position of the molecule, now the intermolecular forces are going to act between them in order to bring back these molecules to its original position. So, as the intermolecular forces are trying to restore the molecules to its original position, as the intermolecular force between the molecules is trying to restore the molecules to its original position, the intermolecular forces will be known as the restoring force here. So, whenever I am applying the deforming force, inside a force is getting generated. Due to the interaction between the molecules, as the molecules want to go to their equilibrium position. As the equilibrium wants to go to their equilibrium position. So, the restoring force is acting now in the spring, which is known as the spring force in the spring. You can see here, spring force is nothing but here is the restoring force. So restoring force is getting generated in the spring once I am applying the deforming force. Now the molecules are trying to come back to its original position. But you can see here is the deforming force and here is the spring force. As I am applying the deforming force, you can see the change in the size of the spring. That means the molecule position has been changed. That means the deforming force is greater than the restoring force. The deforming force is greater than the restoring force. That is why the spring size has been changed. If I am the object, if you are applying 5 Newton from here, and from the opposite end, if you are applying the same 5 Newton force, then I will be at the rest state. If you are considering me as a molecule, then if you are applying here 5 Newton and from the opposite side I am applying 5 Newton, then I am at the rest state because the net force on me is 0. The net force on this object is 0. Same if I am applying the deforming force on this molecule. So this molecule, inside this molecule, a force is going to be generated which is known as the restoring force, and the direction of the restoring force will be in this direction. You can see here why I given this direction, because this molecule is trying to go back to its original position. As this molecule is trying to pull this molecule, so every molecule of this object will try to pull every molecule to its original state, as it is in the deformed state right now. But even though every molecule is trying to bring back, every molecule is trying to bring back to its original position, even though the restoring force is present, as the deforming force is more than the restoring force, the molecule is not able to regain its original position, to restore its original position, and they are getting deformed. That is why I wrote here, deformed force is greater than the restoring force. But one more point you can write here is that whenever they are applying the deforming force, exactly opposite to that, restoring force is going to be get generated. You can see here, my deforming force is in this direction, but every molecules are pulling other molecules in this direction. You can see here, every molecule is trying to retain its original position, to regain its original position, to restore its original position. Every molecule is trying to do so. Every molecule is trying to go in this direction. Every molecule are pulling other molecules in this direction in order to make sure that other molecules, those who are displaced, those who are deformed, to get back to their original position. So here, the deforming force is going to be greater than the restoring force. That is why the spring is changing their size. You can see the change in the size. And you can see the restoring force always acts opposite to the direction of deforming force. So, this is the two things you learnt here. So, each and every molecule, if you are deforming, each and every molecule of an object, if you are deforming the object, then each and every molecule will get disturbed from the equilibrium. It will get disturbed from the equilibrium. Then a force will get generated inside the body, will be known as the restoring force, which is trying to pull back all the molecules to their original state. And it is all happening here. So once I'm removing my deforming force, here there will be no force, then only the restoring force will be there, and you can see the restoring force action as every molecule will come to its original state. As every molecule will come to its original state due to their intermolecular of attraction or intermolecular force of repulsion, every molecule will come to its original state because of this restoring force. And this restoring force is nothing but the intermolecular force, as we studied in the previous class. So after I am removing my deforming force, you will be able to see the restoring force from outer view, from outside. But even though we are not able to see the restoring force inside the object when I am applying the deforming force, even though I am not able to see the restoring force when the deforming force is applied, but actually the restoring force is getting generated already inside the body. Inside each and every molecule, the restoring force is getting generated. Each and every molecule is trying to go back to its original position. Each and every molecule are pulling other molecules to bring back to their original state. So you can see here, so the restoring force is already got generated, but you are unable to see just because the deforming force is greater than the restoring force. The restoring force are acting on the molecules, and these molecules are nothing but it is the molecules of the solid. That is why we are unable to see. It's happening inside that object. It is happening inside the spring. That is why you are unable to see the restoring force. But you should have to know the restoring force. Whenever I am applying the deforming force, the restoring force is already getting generated. Once after the removal of a deforming force, the restoring force is showing its action. I am having one more example for you. You can see is that I am taking a rod. What I am doing is that it's a rod. I am just applying the deforming force here. As I am applying the deforming force here, what I am observing is that how much ever I am giving the deforming force, how much ever I am applying the deforming force, the body is not getting deformed. How much ever I am applying the deforming force, the body is not getting deformed. For example, you can see this. It's a rod. I am trying to pull this rod, but it is not getting deformed. As you can see this rubber, I am trying to deform this rubber, and you can see the elongation in the rubber. There is a change in the size of the rubber. The size of the rubber has now been increased. But you can see the same in the rod. I'm trying to pull the rod, but there is no change in the size or the shape of this object, of this rod. Can you see any change in the size? Can you see any change in the shape? No. You are not able to see the change in the size or change in the shape of this rod, even though I am applying the deforming force. So here there is no restoring force generated. No. Is that here no restoring force generated? Yeah. Is that there is no restoring force generated? No. Restoring force is getting generated. See here, my dear friends. As here the molecules of the rod is present, I am applying the deforming force of these two molecules. If I am applying the deforming force on these two molecules are not ready to leave its position. They are not ready to leave its position. Whenever I am applying the deforming force, a restoring force is getting generated exactly opposite to the deforming force, and this restoring force is not leaving this molecule to leave its position. As this restoring force is not leaving this molecule to leave its position, the body is not getting deformed. The rod is not getting deformed. That's why, how much ever I am applying the deforming force, inside this rod, the restoring force is getting generated, and the restoring force is making sure that this molecule should not leave this equilibrium position. So what I can say is that how much force ever I am applying, the same exact force is acting opposite to the direction of the deforming force. Here I can say is that deforming force is equal to the restoring force. Deforming force is equal to the restoring force. You may have a doubt that how this rod is showing the elasticity phenomena. How this rod is showing the elasticity phenomena. You can see here, my friends. So whenever I'm trying to deform this object, inside the molecular force is getting generated, which is known as the restoring force, and this restoring force making sure so that this molecule should not move anywhere. This molecule should be in the position of the equilibrium. It is not letting the molecules to move, even though when I am applying the deforming force. That means it shows whatever the force which is getting generated inside, it is exactly equal to the deforming force. If you are applying 5 Newton on this side and exactly opposite to me, if you are applying 5 Newton, then I will not move anywhere. If your force in this side is greater than the opposite force, then definitely I will move backward. But here it's not the condition so. Here it is a condition, this molecule is not moving even though I am applying the deforming force. This molecule is not moving even though I am applying the deforming force. Any molecule of this rod is not ready to leave its position just because the restoring force is getting generated whenever I am applying the deforming force exactly opposite and equal to the deforming force. That's why this rod is not ready, is not willing to leave its shape or to leave its size. That means it is opposing the deforming force. Now I'm going to give a very, very good definition for the elasticity. It is a second definition for the elasticity, my dear friends. See here. The tendency of an object to oppose any change in its size or shape. This phenomena will be known as elasticity, and the objects will be known as elastic objects. As you can see here, the tendency of an object to oppose any change in its size or the shape. So, whenever I am trying to change the size of the shape by applying the deforming force, if any object is opposing that force, is not ready to change its size and shape, then that object will be known as the elastic object, and the phenomenon which is occurring there is that elasticity. So you can see here, this body, how much ever I am applying the deforming force, this body is not changing its size, not changing its shape. I am applying the force, but this body is not changing its size and changing its shape. You can see here, instead of that, it is opposing that force. You can see here, exactly by creating the same restoring force. So as the restoring force and the deforming force are equal, the body will not change its size, will not going to change its shape. As it is not changing its shape, as it is not changing its size, but it is opposing the deforming force, that means it is showing the phenomena of elasticity, which is a second definition of elasticity. So the tendency of an object to oppose any change in its size or shape will be known as elasticity. It is a phenomena of elasticity. So if I am applying the deforming force, if I am unable to change the size or the shape of an object, it doesn't mean that it is not showing the phenomena of elasticity. It is showing the phenomena of elasticity. Each and every molecule are experiencing this deforming force. Whenever each and every molecule of this rod experiencing the deforming force, so whenever I am going to apply the deforming force, a restoring force is going to be get generated. When molecule is experiencing this deforming force, the same molecule is going to experience the same restoring force. As this molecule is not moving, that means this rod is in stable equilibrium. That means every molecule in this rod are in stable equilibrium. How much ever I am applying the deforming force, if this rod is not moving, that means the rod is also in stable equilibrium. Inside the rod, the molecules which is present, they are also in equilibrium. That means whatever the restoring force which is getting generated inside the rod will be equal to the deforming force what I applied. That is why I wrote the restoring force will be equal to the deforming force, and this condition will be satisfied only in the equilibrium conditions. You can see here this rod is not moving. That means each and every molecule is in equilibrium. That means how much ever deforming force I am applying each and every molecule of this rod, the same exact opposite force they are experiencing by the restoring force. That is why each and every molecule of this rod is in the stable equilibrium. So restoring force is equal to the deforming force. Now we are going to study about the stress. Stress. What is stress? The internal restoring force per unit area. Internal or restoring force per unit area. That means how much ever I am applying the deforming force, whenever I am applying the deforming force, how much amount of restoring force is getting generated inside the body will only be known as stress. Once again, whenever I am applying the deforming force, whenever I am going to apply the deforming force inside the body, the restoring force is going to get generated. So how much amount of restoring force is getting generated inside the body per unit area? Actually, it's not an area, it's an area of cross section. Or you can say cross sectional area. For example, if I am considering this as a unit of area of cross section, then how much this area of cross section experiencing the restoring force, how much force is getting generated inside this unit area, how much restoring force is getting generated inside this unit area when I am applying the deforming force is only known as stress. So what is the formula for the stress? Representation for the stress is a sigma. Sigma is equal to force upon area. This area is nothing but it is a circular, it is a cross-sectional area. This force is nothing but the restoring force in the rod as the restoring force is equal to the deforming force, we can also write, instead of restoring force, deforming force upon area. When we can write the deforming force upon area, when the object is in the equilibrium condition, whenever I am applying the deforming force, I am not able to see any change in the size and any change in the shape. Then at that condition we will say that the object is in equilibrium. That means how much ever I am applying the deforming force, the same amount of force is getting generated inside the body, exactly opposite to the deforming force. That is why each and every molecule of that object is in the stable equilibrium position. Right? So at that time we will write restoring force is equal to the deforming force upon area. Mostly in our syllabus, restoring force will be equal to the deforming force. That means mostly in your syllabus, the objects are going to be in the equilibrium mostly. Okay? So it is about stress. Stress is a tensor quantity. What? It's a tensor quantity. You can say it's like a scalar quantity. It's not in your syllabus, so nothing to worry about this one. So it is all about stress. So internal restoring force per unit area of cross section. How much, whenever I am applying the deforming force, how much amount of restoring force is getting generated inside this body per unit area of cross section is only known as stress. So we've seen about the stress. In the next lecture, we will see about the types of stress. So you don't take any stress. You do hard work. You keep studying, you keep moving ahead. Instead of wasting the time in other things, you can do so many things. You can study well, and your future will be so bright. You should have to understand, my dear friends. Okay? Take care and do well. Bye. If you like this lecture, then comment it, subscribe it. If you have any doubt or any query, then comment it in the comment section. Okay, take care.